Hello students, so I hope you are happy and safe. Okay, so this is the last video of Heron's formula. I know that this Heron's formula for you, it must be very easy chapter as it has only one formula, that is square root of s into s minus a into s minus b into s minus c. In exercise 12.1 we have dealt to find the area of triangle. Now for second exercise, that exercise 12.2, already we have completed. Out of 9 sums, I think we have done 5. So that also has to deal with the Heron's formula, and we had used the previous formula what you have studied. Okay, so let's go into this next sum, that is 6th sum. So I am just going to explain 6 and 7. So 6, 7th and 8th will be for homework, and 9th I will solve this. Okay. 6th sum says that an umbrella is made by stitching 10 triangular pieces of cloth, okay, of 2 different colors. So 5 of different color and 5 of other color. Each piece is measuring 20, 50 and 50. So here I have just drawn the rough diagram. So this 20 is this 20 centimeter, 50 and this is 50 centimeter. So 5 pieces, okay. Now how much cloth of each color is required? So you have to find out for one color, that means for 5 pieces, what is the total area that is required, right? So this is very simple. So we just have to find area of one triangle, and what is our A? You can assume A is 50, B is 50, C is 20. So you will use Heron's formula. First you will find S, A plus B plus C upon 2. Then you will find area of triangle. Area of one triangular piece you will find. Therefore area of one each color type, that is they are asking area of each color. So area of each color, that will be 5 into whatever you get answer, that is square centimeter, will be your answer. Correct? Coming to the 7th sum, a kite is in the shape of a square. Can you see a square? They have not labeled the diagram, not necessary. With a diagonal 32 centimeter. So you all know that we are going to use your diagonal property, that squares diagonals are equal. So here this is 32 centimeter. Similarly, this is also 32 centimeter, right? And an isosceles triangle. So this is an isosceles triangle. Base is 8 centimeter and the sides are 6 centimeter. Each is to be made of 3 different shades. Means here this is of different one shade. Second area this is of one shade, and this is third is of other shade. How much paper of each shade has been used? Now as you know that this 1 and 2 is made up of a square. This is area of one triangle and this is area of one triangle. So obviously area of these two shades will be equal, right? Now here to find, they have just given the diagonal centimeter. Diagonal length they have given, nothing else they have given. So you have to use the properties of a square that you have learned in the previous classes, right? So we all know diagonal of a square bisect each other. So if this is 32, so here this is, if the whole thing is 32, so we know this is 16, this is 16, this is 16 and 16 half of 32, right? So can you find the area of this triangle very easily? Can I use half into base into height? So this is half into 32 into 16 will give you area of this one triangle. That same area will be equal to this, correct? And this area of this chota piece, a small triangular, already it is given as an isosceles triangle, correct? Also you can use isosceles Heron's formula. So A is 6, B is 6 and C is 8 centimeter. So you can find the area of this, correct? So area of first triangle, second triangle and third you can find very easily, correct? 8th one is also very similar, where it is dealing with a triangular tiles. You have to find area of one triangular pieces, multiply with how many, and cost you have to find. It is very easy, so I am not going to explain. Now this question number 9th is very important, and we have done this in question number 2, if you remember, the aeroplane wala, where we have done a small part of trapezium part. Okay, the same thing we will deal this sum. 9th one I will just explain you. A field is in the shape of a trapezium. So there is a field which is in the shape of a trapezium. Parallel sides are given 25 and 10 meters. So I have written 25 and 10. Non-parallel sides are 14 and 13. Find the area of the field. Now you all know that area of a trapezium formula is half into sum of parallel sides into height. We all know this formula, correct? So we know the parallel sides. So the only challenge is how to find the height. So I think there are different methods, but I think this is the easiest way, and I hope you should also follow this. right? But you can do it other way also. Now let's say you in that second question which we did in the plane area, where it's a plane aeroplane, the paper is made up of, the paper is in the shape of aeroplane, and we found out the area of the trapezium. Same method I'll follow so that it is easy for you to connect, right? So here I have to do a construction. So I will take the construction as draw BE parallel to AD. Okay, draw BE parallel to AD I will take, and our aim is to find height. So I'll take draw BF perpendicular to DC. See, our aim is to find height. Okay, so once we find height, we can find the area of the trapezium, that is half into sum of parallel sides into height. Correct? So for this we have done the construction that draw BE parallel to AD and draw BF perpendicular to DC. Correct? This is solution. So we have drawn this construction. So now you find that this ABED becomes a parallelogram. Why ABED is a parallelogram? Because we know that AB and DC is a trapezium. So AB is parallel to DC. So we know this. And we have done the construction that AB and BE is also parallel. So from this we can conclude that ABED is a parallelogram. Definition of a parallelogram: if opposite sides are parallel, then it is a parallelogram. So here we have that since AB is parallel to DC and AD is parallel to BE, therefore I can conclude quadrilateral ABED is a parallelogram. I hope you all agree. If it is a parallelogram, then again we will use a property. I will just divide this into two, so that it's easy. So if it is a parallelogram, I can say AB will be equal to DE and AD will be equal to BE. The sides will be equal, okay? So this implies AB will be equals to DE, and that is will be equal to 10 meter. Do you all agree? Similarly, I say that AD and BE will also be equal to 14 meter. Just see here, AD is 14, this is also 14. Now here I come to know this is 10, so this is also 10. So this DC is total 25. So what will be EC? 25 minus 10, that is 15, correct? So here I write therefore EC will be equals to, what is EC equals to? DC minus DE. That is 25 minus 10, that is 15 meter. I hope this is clear. So we have got this is 15 meter, correct? And this is 14 meter. So by using Heron's formula, because now in this triangle, can you say this is 14, this is 13, this is 15 I have got, correct? So by Heron's formula, can I find the area of this triangle? Very easily we can find. Once we have done with the area, then I can use the traditional formula, half into base into height. We get the height very easily, correct? Let's start with. So let's consider the triangle. Consider triangle BEC. So let's assume let A equal to 14 meter, B equal to 15 meter. This A, B, C you can assume anyhow, and C I have assumed 13. So our aim is to first find the area. So area formula, first we will find S, A plus B plus C upon 2. So 14 plus 15 plus 13 upon 2. So here we'll get 5 plus 3, 8, 12, 1, 2, 3, 4. So 42 upon 2, that is 21. Correct? So now we'll use the formula. So area of triangle BEC equals to square root of, correct? So S into S minus A into S minus B into S minus C. So yes students, when square root comes, our first aim should be that we write it in the form of pairs and get rid of the square root sign. Let's do that. So here we have S as 21. This is 21 minus 14, correct? 21 minus 15 and 21 minus 13. Here we have 21, and what is 21 minus 14 will give you 7. Here we'll get 6 and here we will get 8. I hope I have done correct. So now let's try to split. I know that 21 can be split as 7 3s are 21, and the 6 we will write as 2 3s are, and 8 we will write as 2 4s are. Okay, let's bring it in the form so that we can take in pairs. So here I wrote 7 3s are. This 7 I wrote as it is. 6 I am writing as 2 into 3. 8 times splitting us 2 into 2 into 2. Can we do that? Or 2 into 4? Anything. So here, out of this 2, here, 2, 7, and let's make a pair. Correct here. And here we will take out of this 2, 7, 1, 7 out. Out of this 2, 3, 1, 3 out. Out of this 2, 1, 2 out. And out of this 2, 1, 2. So we have just collected in pairs and brought one number and got rid of the square root sign in this case. So we got 7 3s are 21, 42, 42 into 2 will be 84. It is meter square. So 84 meter square. So beautifully we got the area of the triangle. Correct? Now our aim is to find the height. So let's find. So our traditional formula, area of triangle BEC equals to half into base. Base is EC into height BF. Correct? So let's write area of triangle we got is 84. So 84 equals to half into 15 into height. So let's assume this is H. Right? We can take as H. So here I get 84. This 2 goes here. It becomes multiplication divided by 14. Okay, so we are not getting a proper integer. So here we have 8, 168 divided by 15 equals to H. Let's divide and find quickly. 168, 15, 15 ones are 15. Here we have 1, 8, 15 ones are 15. Here 3.2 and 15 twos are correct. We got 11.2 meters. So here our aim is fulfilled. So we got the height. So can we find the area of trapezium now very easily? So area of our trapezium, that is quadrilateral ABCD, is half into sum of parallel sides. Which are the sum of parallel sides? 14 plus 25. So here I write 14 plus 25 into height. No, it's not 14. I'm sorry, it is 10. Correct? It is 10. Okay, 10 plus into height is 11.2. So here we have 35 upon 2 into 11.2. So we divide 17.5 into 11.2. So this calculation you all students do and get the area. I hope this chapter has been easy for you all throughout. Okay, so please do this, and the remaining worksheet sums answers also will be sent, and this chapter is complete. Bye. Thank you.